Good day viewers, welcome to my YouTube channel. This video describes how to determine the concentration of a stock solution. Concentration is defined as the amount of a substance in a specific volume of solution. The most common unit for concentration is molarity, where molarity is given as the amount in moles or number of moles of solute over the volume of the solution, where volume is measured in liters and not in milliliters. All right, so now I'll be explaining how to determine the concentration of a stock solution from your Winchester bottle. Because for you to dilute your concentrated acid to a more dilute form, you need to know the initial concentration of the acid using your dilution formula M1V1 equal to M2V2, where this is the initial concentration and this is the initial volume. This is the final concentration and this is the final volume. So for you to dilute this concentrated acid to a more lower concentration, you need to know the initial concentration of the stock solution, which is what we'll be doing today. So for you to do that, the information you get it from the assay. First, you need to know the molecular weight of the acid, which you get from what you have here. The molecular weight of acetic acid is 60.05. So after getting the molecular weight of the acid, the next thing you need to get is the percent concentration, which you can see here. Here we have 99.5% concentration. Now, what this means is that the solution contains 99.5% of the pure acetic acid by weight, meaning 99.5% of the total weight of the solution is acid, while only 0.5 is likely to be water or other impurities. So from 100 grams, for every 100 grams of this acid, 99.5 grams of it is acetic acid, while the remaining 0.5 to give you a total of 100 is likely to be water or any other impurities. Okay, so the percent concentration is 99.5, meaning this acetic acid contains 99.5 grams of the acetic acid, while the remaining 0.5% is likely to be water or any other impurities. All right, so after getting the molecular weight, the percent concentration, the next thing you need to get is the specific gravity, which you can find here, which is the weight per mole at 20 degrees Celsius. So the specific gravity for acetic acid at 20 degrees Celsius is 1.05 grams. So our specific gravity is 1.05 grams. All right, so when you've gotten those three information, molecular weight, percent concentration, and the specific gravity, with the information you have here, you can use it to determine the initial concentration of the acetic acid from this Winchester bottle. All you have to do is first you multiply the specific gravity with the concentration. Now this specific gravity here, it's 1.05 grams per cm cube, meaning 1 cm cube of the acid weigh 1.05 grams. All right, so that's what the specific gravity tells you. So we have 1.05 grams per cm cube. For every cm cube of the acid, it weighs 1.05 grams. So you multiply it with the percent concentration. Take note, percent is over 100, which is 99.5 grams over 100 grams. All right. So when you multiply this, 1.05 grams, take note, grams here, we'll cancel grams here. If you multiply this, you have 104.5 475 grams over 100 cm cube. All right, now from the definition of concentration we have here, which is in molarity, we said concentration is amount in moles, number of moles of the solute over volume of solution. So now let's get the amount in moles. And you know that amount, to get the amount in moles, it is mass over molar mass. And our mass, what we have here is 104.475 grams over the molar mass of acetic acid, which we have here to be 60.05 grams per mole. All right, so when you divide this, you have 1.74 grams. All right, so our amount in mole is 1.74 grams over the volume of solution. Take note, volume is a liter, so here we're having 100 cm cube. So converting it to dm cube by dividing with 1000, you have 0.1 liters or dm cube. All right, so when you divide this, you have 17.4 grams per liter or 17.4 molar. So this is the concentration of this stock solution. So now if you want to dilute it now to a lower concentration, let's say you want to prepare 100 cm cube of 0.1 molar acetic acid. All you have to do, your dilution formula M1V1 equal to M2V2. All right, so the initial concentration is what you've calculated now to be 17.4 molar times. So now you want to determine, you want to look for what volume of the stock solution you need to measure as to prepare 100 ml or 100 cm cube of 0.1 mole acetic acid. So that's what you're looking for. Then your M2, which is your final concentration, is 0.1 times, you want to prepare it to 100 ml or 100 cm cube. All right, so when you make V1 the subject of the formula, you get your answer. So that's what you need to do, get the initial concentration. Let's do one other example. Now this sulfuric acid, as usual, the major thing you need to get first, we start by getting the for the case of sulfuric acid, we start first by determining the formula weight. The formula weight for sulfuric acid, you can see it here to be 98.08 grams per mole. Then the next thing you get is the percent concentration. Take note here, there's a little or slight issue here. Here we're having 97 to 99% of the sulfuric acid. So you can take the average, which is 97 plus 99, divide it by 2. When you do that, you should be having 96% concentration of the sulfuric acid. Now what this means is that for every 100 grams of the acid, 96 grams of it is your pure sulfuric acid, while the remaining 4 grams of it is likely to be water or other impurities. Okay, so we're having 96 grams or 96% of it. Then the next thing is the specific gravity. So the specific gravity here is 1.835 grams per cm cube. So as usual, we multiply the specific gravity with the percent concentration, which is 1.835 grams per cm cube multiply, take note this percentage which is always over 100, 96 grams of the acid diluted to 100 grams. Okay, so once you do this, you have 176.16 grams, all right, over 100 cm cube. So what this means is that 100 cm cube of this acid solution contains 176.16 grams of the acid. All right, so from our formula, molarity is equal to amount in moles over volume of solution. We all know that volume is in liters. Okay, so now we already have the mass here. All we need to do, we want to look for amount of this 176.16 grams. So we start first by saying amount is equal to mass over molar mass. Here the mass we have is 176.16 grams over the molar mass, which is our molar mass is 98.08 grams per mole. So once you divide this, you have approximately 1.80. Okay, so our amount here is 1.80 over converting cm cube. Take note, this is cm cube. We need to convert it to liters. So you know, 1 cm cube, 1 liter, 1 liter is equivalent to 1000 cm cube. So converting this one to a liter, you divide with 1000. You divide with 1000. So when you do that, you have 0.1. Now dividing this, you have 18.0 mole. So this is the initial, this is how you get the initial concentration, the original concentration of a stock solution, which is 18.0 mole. So if you want to dilute this to any amount with your dilution formula, know that M1, which is your initial concentration, is 18.0 mole. All right, so now let's take another example. This is hydrochloric acid. So we have hydrochloric acid here. As usual, we'll get the formula weight first. The formula weight for hydrochloric acid, which you can see here, the formula weight is 36.46, which we have here to be 36.46, and the percent concentration, we have a range here which tells us is 36.5 to 38.0. Just take the average, divide by 2, and then you arrive at 37.25%. And then the specific gravity also is a range here. Take the average of the specific gravity here. If you take the average of the specific gravity, we'll arrive at 1.186 grams. All right, so it means 1.86 grams, 1 cm cube of the acid weighs 1.186 grams. Okay, so as usual, you multiply it with the percent concentration. Take note, it's always over 100 percentage, which is 37.25 over 100 grams. All right, because this is the weight, the percent weight of the acid. That's why it is in grams. Okay, so you multiply this together, you will have 44 0.1785 grams over 100 cm cube. All right, as usual, molarity, which is our concentration, is amount in moles over volume in dm cube. Okay, so amount first, we can convert the grams there to amount. We know that amount is mass over molar mass. So the mass there we have is 44.1785 grams over the molar mass of the acid is which is the formula with is 36.46 grams per mole. So dividing this gives you approximately 1.21. So our amount here is 1.21 mole. Take note, 1.21 mole, grams cancel grams. So over the volume, converting 100 cm cube to dm cube, we have 0.1 dm cube or liter. So when you divide these together, you have 12.1 molar. So this is the initial concentration or the original concentration of this stock acid solution in the Winchester bottle. So let's take another example. This nitric acid. Nitric acid is HNO3. First, we start by getting the formula weight of the nitric acid, which is 63.01 grams per mole. Then the percent concentration, here we have a range. It says 69 to 72 weight per weight. All right. So getting the average of it, you have 70.5%. All right. So the percent concentration of the acid is 70.5% weight, which is weight per weight. All right, which means 70.5 grams of the acid diluted to 100 grams. All right, so from this pure acid, 70.5 grams of it contains acid, while the remaining part of it is likely to be water and other impurities. So that's for that. And then the specific gravity of the nitric acid is by the other side of it, actually. But if you checked online, the specific gravity of nitric acid at 20 degrees Celsius is 1.42, that's grams per cm cube. So as usual, is 1.42 grams per cm cube. 1 cm cube of this acid weigh 1.42 grams. So you multiply it with the percent concentration here, which is 70.5 grams over 100 grams. All right. So when you multiply this, you have 100.11 grams over 100 cm cube. All right. So 100 cm cube of the acid weigh 100.11 grams. Okay. So as usual, our molarity is given as the amount in moles of the solute over volume of solution in liters. All right, so we convert this mass to mole and then the cm cube to liters. So we know that amount is equal to mass over molar mass, and The mass here, we have it as 100.11 grams divided with the molar mass of nitric acid, which is 63.01 grams per mole. All right, when you divide this, you have approximately 1.59 mole. All right, so substituting it inside here, your amount is 1.59 mole over volume. 100 cm cube to a liter is 0.1 liter or dm cube. So when you divide this, you have 15.9 molar. So this is the initial or the original concentration of the stock nitric acid solution. So that is how you determine it. So if you are faced with any difficulty or situations like this, just check the assay here. You see those information from there. You can calculate the initial concentration of any stock solution. All right, so we have another one here, which is N-hexane. So now let's see if we can get the initial concentration of this N-hexane. So the first thing we do, we'll get the molecular weight. All right, so the molecular weight of hexane is 63.01. You can confirm that hexane is CH2, CH3, CH2 to 4, then CH3. All right, so if you calculate the molecular weight, you have 63.01 grams per mole. All right, so the percent concentration here we have is 99%. So 99% concentration. And then the specific gravity at 20 degrees Celsius, we have a range of figure here. So when you take the average of the specific gravity is 0.659, that is gram per cm cube. So as usual, you multiply this specific gravity grams per cm cube with the percent concentration, which is 99 grams over 100 grams. So once you do this, you have 65.241 grams over 100 cm cube. All right, so you will go over to molarity, where molarity is amount in moles over volume of solution in liters. Okay, so we convert these grams of the acid to mole so that we can equate it or substitute into our equation, and then we convert cm cube to liters. All right, so let's start with the amount first. Amount is given as mole over as mass over molar mass, where our mass here is 65.241 grams and the molar mass of hexane is 63.01 grams per mole. So once you divide this, you have 1.04 mole. So our amount here is 1.04 mole. Then converting volume to liters, it gives 0.1 liter or 0.1 dm cube. So when you divide this, you arrive at 10.4 molar or 10.4 mole per dm cube or mole per liter. So this becomes the original concentration of this stock solution. So here is a simple one for you to try. I want you to try this, then leave the answer in the comment section below. So this is absolute ethanol, and you have the concentration here to be 99.5% weight by weight, and the specific gravity, you have the specific gravity to be 0.7897. All right, and here is the molecular weight to be 46.07. So I want to determine the original concentration of this stock solution. Drop the answer in the comment section below, and also try this for phosphoric acid. I also want you to determine the concentration of the initial concentration of a stock solution of phosphoric acid. The formula weight for phosphoric acid is 98 grams per mole. All right, most of the commercial product comes in 85.5% concentration. Then the specific gravity at 20 degrees Celsius is 1.70 grams per cm cube. All right, so I want you to determine the concentration of its stock solution with this information here for phosphoric acid and for ethanol, and drop the answer in the comment section below. If you want to prepare 200 ml of 0.2 mole of the phosphoric acid, which is H3PO4 of the phosphoric acid, what volume of the initial stock solution do you need to measure? Okay, so that means you're using your dilution formula. You want to dilute the original concentration to 0.2 molar. So you have M1V1 equal to M2V2. So first you get your initial concentration, which you're asked to calculate with the information here. Then now you want to look for what volume you need to measure out to dilute to get 0.2 mole. That's your final volume is 0.2. So your final concentration is 0.2 mole, and then your final volume, which is V2, is 200 ml. So get that also and drop the answer in the comment section below. Thanks for watching.